Hi, everyone. Welcome to the session of DataWorks that I'm chairing on situational awareness. And I should have gotten that out ahead of time. What's our full title? Welcome to the session on situational awareness, autonomous systems, and digital engineering in T&E. We will have 3 presenters today. Our first presenter is Dr. Miriam Armstrong. She's coming to us from IDA. Dr. Armstrong is a human factors researcher at IDA, where she's involved in operational testing of defense systems. Her expertise involves interactions between humans and autonomous systems and psychometrics. She received her PhD in human factor psychology from Texas Tech University in 2021. And her co-authors on this presentation are myself, Janna Mantua, and Brian Vickers. Take it away.
Great, thank you for that introduction. And can everybody hear me okay? All right, fantastic. So as Elizabeth just mentioned, I'm on a team with some other researchers here at IDA. We are looking into how to improve the ways that we measure situation awareness within operational testing. Okay, so before I get into talking about our situation awareness measures, I do want to address an elephant in the room, which is that I'm using the term situation awareness rather than situational awareness, which I assume most of you are more familiar, perhaps more comfortable using. So why am I doing that? What is even the difference between situation awareness and situational awareness? For the most part, this is a semantic or even a cultural difference between the academic use of the idea of situation awareness and the more colloquial use of situational awareness. So because we will be focusing today on the scientific measurement of situation awareness, that's what I'm using for essay. It also is a little bit more well-defined than some of the loosey-goosey ways we use situational awareness. And I will go into some of that more structured definition of situation awareness in just a few slides. But first, I want to begin by arguing for the need for situation awareness measures generally. Then we'll talk about what SA is. Specifically, we'll focus on Micah Endsley's 3-level situation awareness model. And once we have a shared understanding of what SA is, we'll talk about how we can measure it and how we can promote better situation awareness measurement practices in operational testing. So situational awareness is one of many human systems integration concepts relevant to operational testing. Some others include training, usability, workload, trust, etc. So for these other 4 concepts that I've mentioned, we have some validated measures that we consistently use in operational testing. In this case, these are all survey measures. However, for situation awareness, we don't currently have a standard measure that we use within operational testing. And this is a problem. Sometimes we're not really getting good measures of situation awareness, but we really would prefer to know that during operational testing rather than once the system is fielded. And in the future, it's becoming increasingly important to measure SA because some of the additional challenges inherent in our future systems, or some of our current systems that are becoming more prevalent, such as human-machine teaming and human AI teaming. Right, in this case, the human in the team may not have full situation awareness of the situation, but hopefully the team will have full situation awareness. So even being able to accurately measure that human situation awareness isn't going to tell us everything we need to know about that team. And then in other types of systems like multi-domain operation contexts, a lot of the purpose of MDO is to increase comprehension, increase situation awareness. And so in order to measure the effectiveness of that type of a system, we need strong measures of situation awareness. Now, this talk is going to focus on these kind of individual measures of situation awareness rather than, team situation awareness or situation awareness across domains. And that's a starting point that we really need to get better at right now, begin the transition to robust measures right now in order to prepare for these increasing essay challenges on some of these more complex systems. So now let's talk about what essay actually is, and we will look at one of the most well-respected academic models of situation awareness. This comes from Micah Endsley. And in order to be, so the first level of situation awareness, or the first thing to recognize when we're talking about situation awareness, is that people are being aware of their environment, right? So everyone exists in some sort of operational or environmental state. Oh, that's right, I'm not using the, all right. They exist in some sort of operational state, that's what they're having their awareness of. And now, according to Endsley's model, there are 3 different levels of situational awareness or situation awareness. The first being the perceptual level, right? So the information that you're receiving in terms of, sound waves or visual information. This perception is the first level of situation awareness. Then you use that data that you've perceived in order to kind of comprehend the meaning of what's going on in your environment. So this is level 2, the comprehension level of situation awareness. And the third level is projection of future states and future events. So using your comprehension of the environment to predict what is going to occur in the near future. I want to point out that each level is dependent on the previous level, right? So in order to have accurate projections of future states, it helps to have an accurate comprehension of the current environment. And I also want to point out that according to this model, situation awareness is not all or nothing. It's not necessarily something you have or you don't have, right? You could have a really high level of or a really high amount of level 1 essay without having a high level of level 3 essay. So it's more helpful to think of it along a continuum. You can have better essay or worse essay. Now, depending on someone's situation awareness, that's going to affect the decisions that they make, the actions that they take, and then those actions do tend to affect the environment around them. So situation awareness is a continuing process. You have to be continually aware of what's happening and update your kind of mental model of what's going on. This model of situation awareness can quickly become more complicated if we take into account other factors, such as task and environmental factors that might influence somebody's situation awareness, might influence their decision making. I do want to just mention that these external factors and also individual operator factors do exist. They do influence SA. For our purposes today, though, I'm not going to go any deeper than that. We'll just focus on these kind of 3 level, the core 3 levels of the situation awareness model. To better illustrate what these 3 different levels of SA look like, we have 2 examples. So for example, in Army operations, the S3, they are asking themselves a lot of questions while they're doing their job. Questions like, what terrain features are present? That's related to their perception of their environment, and thus to level 1 situation awareness. Questions like, is the current route accessible to this unit? That's a comprehension of the environment. That's level 2 SA. And then, how will terrain affect enemy course of actions? To answer that question, you need to project into the future. So that's level 3 situation awareness. Another quick example in air traffic control, the operator may need to know things like, what is the current heading of the aircraft? That's based on perceptual information, that answers based on perceptual information. Is the aircraft on the intended course? That's comprehending the situation. And then will the aircraft overlap with another aircraft in that airspace? That's projection. So, how do we measure situation awareness? I can start off by talking about what we currently do in operational testing, or at least what we most frequently do in operational testing. And that is to come up with some custom question for our test and ask operators things like, how was your SA during the mission? Or how did the system contribute to SA? One of the benefits of this approach is that these types of questions are very easy to implement. They're easy to come up with, easy to write, and easy to administer to an operator. However, there's also a lot of cons associated with this strategy. For one thing, it is near impossible for an operator to answer these questions accurately, right? If you're asking them how aware they were of everything around them, by definition, they're not aware of what they weren't aware of. Also, these questions do not account for the 3 different levels of situation awareness. So for both of these reasons, the answers you get from asking these questions are unlikely to reflect ground truth, and thus they might not be very useful. So what else is out there? We're going to quickly walk through some of the other SA measures that are available. Most of these come, at least originally, from academic measurement of situation awareness. So there are a variety of measures out there, and I want to acknowledge that while each has its pros and cons, some are in general of higher quality than others. When I say higher quality, that means that they are more accurate measures and more reliable measures of SA. So if we think of an analogy of this kind of quality ladder, as we climb the rungs of the ladder, we are seeing measures that are of higher measurement quality. And as a quick comparison, those custom single question ways of assessing SA, our current measures, I would not characterize those as even being on the ladder. They're more accurately somewhere on the floor. And that's okay, because that means the only place to go is up. So let's start climbing this ladder. First, we'll talk about survey measures of situation awareness. So for surveys, you have multiple questions that the operator will answer related to their situation awareness. These are preferable to the current measures we're using because they are tested and they are more reliable measures. Some popular ones include the SART and the SABARS. I will go into both of those measures in a little more detail later. Typically, the operator rates their SA. They complete the survey at the end of a task, or in OT, we would say at the end of a mission. And these surveys can sometimes be tailored to a specific system or a specific mission type, specific operator, right? So there are a lot of surveys, including the SART, where it's system agnostic. No matter what kind of system you're testing, you can give them this same survey. And then there are other survey measures where you really do have to tailor it depending on what exactly you're testing. So there are different survey measures out there, but in general, they are easy to implement, right? You just hand someone a piece of paper. They are non-intrusive because you're not conducting these surveys during the mission, just afterwards, so they're not intruding on the mission. And one benefit to these kind of quantifiable survey measures is that it makes it easy to compare situation awareness across different tests. For example, when you're testing different iterations of a system, or perhaps it would make sense to compare the SA of 2 different systems. Some of the trade-offs for survey measures is that the ones that are easier to use do tend to be of lower quality, right? The more you have to tailor the survey, the more upfront time and effort it requires of the tester, but you might get better quality data at the end. Survey measures are inherently subjective measures, so they'll measure someone's perception of their own essay, which may be useful to assess the HSI of a system, but it is worth acknowledging that their perceptions of essay are different than the ground truth, the actual essay that they had. Also, because they are taking these measures after a mission, they are relying somewhat on memory of their situation awareness, and we know that human memory is fallible. So moving up the ladder, the next rung is behavioral measures of essay. So these are any sort of behaviors, any sort of actions that an operator is doing during a mission that might be reflective of their situation awareness. So for example, if somebody is driving a vehicle and they swerve to avoid an obstacle in the road, we can infer that they projected that they were about to collide with that obstacle, and that would have been, a dangerous thing to do. So that gives us insight into their anticipation of future events. That's level 3 situation awareness. Some of the pros of behavioral measures are that they can measure in real time while the mission is occurring. They can measure multiple points during the mission, not just kind of overarching essay at the end of the mission. Many times these measures are non-obtrusive. They're not like hurting or annoying the operator while you're taking these measures, and they do tend to be objective, right? Either they push that button or they did not push that button. The cons are that for operational testing, we would have to limit behaviors to highly observable behaviors in order to measure them, right? So eye tracking is a behavioral measure that might make sense to do in an academic study. It might make sense to do even in developmental testing of a system, but it is inherently not operationally realistic, and therefore we would not want to use it during operational testing. One other con of behavioral measures are that they must be tailored to a mission and to the personnel. So for example, in a in a fighter jet, you would have a pilot and often a weapons officer, a WISO, and while they will be in a very similar environment, they will probably receive similar information. Their jobs are different. They have different goals, and so their essay is likely to be different, and we might need to measure different behaviors that they're doing in order to measure their essay. And as we reach the top of the ladder, we are looking at simulation-based measures of situation awareness, right? So this is where an operator is in a simulation, and then we measure their situation awareness as they're performing a simulated task. The most prevalent, one of the most well-respected techniques is the Situation Awareness Global Assessment Technique, or SAGAT. This is where someone is in a simulator like a flight simulator. Then the simulation stops at randomly determined intervals. During these stops, the pilot will be queried. All the displays go blank. The operator is asked things about their situation awareness that have objective answers, right? So what was your altitude, something like that. Either they get the answer right or they don't. And then the more answers that they get right, that indicates that they have a higher level of situation awareness. So these are great objective measures of essay. These are used to measure all 3 levels of essay, and they strongly this kind of technique the results we get from this type of technique strongly predict performance in a task, which should be relevant to essay. Some cons are that it's not necessarily conducive to operational testing. Again, we want to be in an operational environment, a simulation, and especially a simulation where you're stopping everything and making the displays go blank is inherently not an operational environment. And again, just like I was talking about for behavioral measures, these really need to be tailored to the specific mission, the specific personnel that you are testing. So now we've talked about a variety of, I'll be taking questions at the end if you can wait. Awesome, thank you. All right, so now that we've talked about a few different situation awareness measures, where do we go from here? What do we actually want to do in operational testing, and what have we learned? We've learned that there are some ideas out there that might be useful, but also that the better quality ideas do tend to take a lot more work on the part of the tester to kind of prep these types of measures, to really think about what they're trying to measure and what's related to essay. So currently existing research on essay measurements in operational testing is pretty limited to survey measures. So we're going to need to do a bit of work in order to get high quality behavioral or simulation based measures. And it is worth noting that developing a new methodology is not enough. It also has to be broadly understood and adopted, right? If this is too onerous to create these high quality measures, no one's actually going to do that, and we are sensitive to that. So we propose that at the bare minimum, we can be swapping custom questions for vetted essay survey measures, such as the SART, the Situational Awareness Rating Technique. This is a 10-item survey that is agnostic to the system. You don't really have to tailor it at all. You can just be swapping out your custom survey question or your custom question about essay for something vetted like the SART. Now, this is not a perfect measure. There are known issues with the SART, and at best, it's going to be measuring level 1 essay. So in order to have a more complete picture, we still need to develop better measures. In order to do that, we really need to understand stuff like what behavior and what information in a mission is relevant to operator essay. And the way you do this is with a goal-directed task analysis. That's what is on the screen here. This is the result of a goal-directed task analysis for Army platoon leaders in a military operation in urban terrain. So for these platoon leaders, they have an overarching objective to attack, secure, and hold the terrain. There are multiple primary goals within this objective. For example, they need to avoid casualties, negate enemy threats, etc. And each of these primary goals also has secondary goals, right? Avoid the enemy, maintain troop readiness, defend against attacks, etc. Now, I know that already this is a lot of information and it's probably difficult for you to read, especially if you're in the back row. But the goal-directed task analysis does go a little bit more detailed than that even, right? So within your secondary goal, you might have sub-goals. So within the secondary goal of avoiding the enemy detection, there are sub-goals such as project enemy behavior or avoid dangerous areas. And from here, from assessing these sub-goals, now we can get into, okay, what information do they need in order to achieve these sub-goals, right? And we can come up with level 1 essay requirements. What information in the environment do they need to know? We can come up with level 2 essay requirements, like what do they have to comprehend about a situation, etc. And this will become the basis for things like custom survey measures, for determining which behaviors are related to essay when we are developing more robust essay methodologies. So a better approach, even better than using the SART, would be to combine survey and behavioral measures of SA, right? So we might develop a battery of reasonably easier to implement SA measures based on common behavioral observations that are relevant to SA. And this could include subject matter expert ratings. So for example, the SABARS technique that I mentioned earlier is a technique for determining behaviors that are relevant to SA and using those to develop a survey for a subject matter expert. The subject matter expert will observe performance and then, for example, say, oh yes, this unit leader assigned tasks to squad members based on their ability, like yes or no, did they do that? Going even further, the highest kind of quality that we could do for operational testing would be something akin to that simulation-based measure, the SAGIT technique that I talked about earlier. But instead of putting people in a simulation, this would be a excursion where people are, this is not part of the larger operational test. This is a smaller excursion event that we could use as a simulation, right? They're doing a small excursion, and at various times we would pause what they were doing to ask them questions related to situation awareness. All right, I know that I've gone quite a bit over, but I hope I have questions for time for at least one or two questions. And if you can stick around later, I'd be happy to hear what you have to think about what we're doing here.
We still have about 4 minutes left for questions, so I'll take questions for the room first, and if none of y'all ask questions, then we have more from online.
Ooh. Yeah, oh yeah.
You need a microphone? You do.
Thank you. Can you just briefly remind me, why are simulation-based metrics better than behavioral ones?
Oh, sure. So one of the benefits of simulation-based measures is that we can look at both observable behaviors like we would for the behavioral measures, but we can also get into kind of some more internal things that are harder to observe, right? So whether someone knows something, it's hard to observe that. It's a lot easier to ask them whether they know that, and then they can, give you a correct or an incorrect answer. So it gives you this kind of objective measure of basically internal things that are difficult to assess otherwise.
Where would focus groups and interviews fit into your assessment? Because usually during operational tests, we have highly trained operators that can provide a lot of qualitative information that may not be captured in surveys or simulations. So how do you propose folding in those focus groups or interviews?
Oh, that's an interesting question. So at this point, we haven't agreed on a strategy of how to incorporate those kinds of qualitative measures. I would say that in general, they are already pretty good at identifying cases where SA is very low. And so the kind of challenge going forward would be to see if these types of qualitative measures would be a useful way of determining between something like okay SA and great SA. So yeah, that's all I can say towards that right now, but thank you. That's an interesting question.
I think that might actually be all the time we have for this one. But again, I think everybody on this paper is here at DataWorks. Please feel free to grab any of us.
Okay, thank you.